Hi, good morning everyone. Today we're going to continue with FTC and we're going to use FTC to derive a special formula. This is a very special topic in our AP exam. The reason that we're using FTC and deriving to review another formula because we're living in the era that we use computer and calculators. The traditional way to find the antiderivative is good, but sometimes there are functions that we do not want to find the antiderivative by using the old method. We prefer to use our technology to do it. That is why that we created this new way to do the particular solution without really integrating. So let's take a look at the FTC first. If f prime of t, I just change the letter into t, is continuous on the interval from a to b inclusive, then the integral a to b f prime t dt equal to f of b minus f of a, where a and b are real numbers. So what we learned so far, a and b are still real numbers. So now we are going to change a little bit. So we can derive a new way to represent a particular solution of a differential equation. We know that f prime t is a differential equation. So differential equation means derivative. So we say that the integral a to x, we replace a b by x, and f prime dt, and then equal to big F antiderivative f of x minus f of a. So this go into the b, and then this is f of a. So where f of a is a given initial condition. So remember when we solve a differential equation, we always have an initial condition. So right now we say that we're going to add the f of a both sides. So you add f of a and add the f of a. So we got integral a to x f prime of t dt plus f of a equal f of x. So now we're going to get this function, we can rewrite it over. So we say that f of x equal to the integral a to x f prime of t dt plus f of a. And f of a is the initial condition. So this is going to be the particular solution that we have using integral format. So now let's take a look at question number 1. Number 1. So we have g prime of x equal to square root sine x, and g is 0 equal to 4. The question asks you to find the particular solution, g of x, that satisfies the initial condition, which is g is 0 equal to 4. Express your answer with an integral. So that means we have to have an answer integral. We cannot have it without an integral. So how do we do it? So method number 1. So we are going to begin with the information g of 0 equal to 4. This is going to be the a equals 0. And we need to get g of x. So we begin with g of x equal to integral because our question asks use integral. So we're going to use the new method. A is 0 and the b is x. And you put g prime in here. So g prime, you can use t dt, or you can use z dz, doesn't matter. And then plus the initial condition. So which is going to be g is 0. So we're going to write g of x equal to integral 0 to x. G prime, which is square root of sine x, which is replaced by t, and plus initial condition, g is 0. I'm just going to rewrite it over. Now g of 0 equal 4, so I'll replace it by 4. So we finished the questions. So this is our g of x in an integral. So how do we do method number 2? Some people may want to use method number 2 if they find that method number 1 is not that easy. So we just go back to FTC. FTC said that integral a to b, okay, f prime of t dt equal to f of b minus f of a. So in this case, we just change the letter. So we got a equal to 0, and then we got b equal x. So we get 0 to x, g prime dt, and then we got g of x minus g of 0. And then we had 0 to x, g prime, let's go back. So we got square root of sine x, so we put square root of sine t dt. And then we got g of x minus g of 0, which is 4. And then we plus 4 both sides. So we got g of x equal to integral 0 to x square root of sine t dt plus 4. So we get the same answer. So you choose a method you feel more comfortable. We use t dt just to make it look different. Like we said before, t is a dummy variable. If in the beginning you forgot to use t, you just go back to change after you finish. So we finished question number 1a. Let's take a look at question 1b. Question 1b said that use your answer in part A to find g of 2. So in A, we got g of x equal to integral 0 to x square root of sine t dt plus 4. We're going to use this answer to find g of 2. So g of 2, and then now just do substitution. That is why that we want you to get this equation. So from here, once you get the equation, you can find g of 2, g of 3, g of 5, g of 10. So now we're going to get 0, okay, to 2, square root of sine t dt plus 4. Definitely, we're not going to ask you to integrate it by hand. The whole purpose of this, so you can use a calculator to do it, especially when you have a function like square root of sine t. That's not easy to integrate. Now we're going to use our calculator. So today, I'm going to show you. So you're going to type in square root of sine x and sine. You cannot use t. Once you type in that as a y1, and then we go back, second mode, and then we go back to the screen. So let's clear what I had before. So now you are going to press 9, math 9, and then you got to enter 0 to 2. Because I restored my function square root of sine x in y1, so I'm going to was, y was, functions in 1. This is going to be my integral, and press enter. So you got 1.6207. Don't forget to set in radian mode. So we got g of 2 equal to 1.6207 plus 4. So g of 2 equal to 5.6207. So we finished the answer for part B. That's how we use our integral from part A to find the answer. So some people said that, can we use what we learned yesterday to find the answer, g of 2? Definitely. So you can be flexible, depends on the question that you have. If they never ask you to express g of x in an integral first, you can directly to solve g of 2 by using the method we learned yesterday. So now part C, I'm going to ask you to use FTC directly to find the value of g of 2. So for part C, use FTC directly. So that means I integral. I already know g of 0 equal 4. So I'm going to put 0 to 2. And then I'm going to put my g prime. And then I got g of 2 minus g of 0, just like what we did yesterday. This method is still work. You use it depends on the question. So over here we got 0 to 2, and then we put square root of sine x dx equal to g of 2 minus 4. So now we go back. It's the same method over here in the calculator. So we put the integral 0 to 2, and now we stored my y1 as the square root of sine x. So I got 1.6207. 1.6207 equal g of 2 minus 4. And because I have to solve for g of 2, so I need to add 4 both sides. So I got g of 2 equal to 5.6207. So I got the same answer as part B, using 2 different ways to do it. Now let's go to question number 2. Question number 2. The question asks you to find a particular solution for the differential equation. You have to leave the answer with an integral. So that means we have to use integral. You have no choice but use the new method that we learned today. So part A. So because we must read the answer as integral. So your answer had to have an integral as a final answer. So now we are going to put g of x, because the function is g prime and g. Integral, it is a 2, is our initial condition. So I have to put 2 over here. And then this is x, so I put x. I'm going to put g prime and dt. You can put g prime and t. I'm going to skip this. And now we're going to plus the initial condition. It is 2. So I put g of 2. So one more time, this part match. 2 g of 2. So now I'm going to rewrite it. So I got 2 to x. My g prime was x times sine x. So I put t times sine t times dt. And g of 2 is given, which is 6. So now I finished my question. So this is the particular solution for g of x when g of 2 equal to 6. So some people said, I don't like this method, let's try another method. Okay, so let's try method number 2. Integral a to b g prime of x dx equal to g of b minus g of a. So we do know a equal 2. And we do not know b, so we put x. And then g prime is going to be what we had before. Let's look at g prime. So we got x times sine x. So we're going to put t times sine t dt. And g of b becomes g of x. And this becomes g of 2 and match. And then I plus g of 2 both sides. So I got g of x integral 2 to x t times sine t dt and plus g of 2. Now g of x equal to integral 2 to x t sine t dt, and we know g of 2 is 6. So we finish. So it's the same answer. So one more time, you prefer use method number 2, then stick with number 2. If you got method number 1, then you can begin to use method number 1. So I prefer you know both. So sometimes I use method number 1, sometimes I use method number 2. Now let's take a look at 2b. 2b, find the value of g when x equals 4, using the answer that you got in part A. So now we are going to find our answer by using the answer we get in part A. So in part A, we got g of x equal to integral 2x t sine t dt plus 6. So now we're going to get g of 4 equal to integral 2 to 4 t times sine t dt plus 6. So now we're going to enter this in our calculator. So same method, you're going to do your y1, you make it into x times sine x. Then you go back. So the beauty of this, so you can use a calculator and use y1. So math 9, and then we got 2 to 4, and then y1 dx, and then plus 6. So we got 6.116. So we finished question number 2.